Hello. Hello, everyone. Hello. Testing. 1, 2, 3. We are back. For the first time. Hello, Mr. Fish. Can you hear? Audio check, mic check. Can you hear? Audio check, mic check. Audio check, mic check, check, 1, 2. Audio check. We good? Can anyone hear anything? Are we good? Hello, FR Doomer. Can you hear anything? Audio check, mic check. Can you hear anything? Can you hear anything? Audio. Hey, Luppy. We're back for the first time. It feels like forever ago. Can you hear? Clear voice? Hello? Oh, man. Yep, loud and clear. One more thing we gotta do. Yay, lighting. Lighting probably the most important thing. It's been a while. All right, hello everyone. Hello. We are back finally from like a mini vacation. Well, not really, but it just feels like forever. It feels like forever ago now, like 2-3 weeks. 2 to 3 weeks. Last time we were here. Yeah, and now we're in November, and we're gonna start to wind down. Yes. For those of you joining in who are new, hello, I'm Ming Chow, Associate Teaching Professor at Tufts University. And this is Introduction to Security. Now, today is going to be, well, I don't know what to make of the reaction for today. This could go either way. It could be really, really short and boring, or it could be a never-ending conversation. Today's going to do really, really bad code. Really, really bad code, which will lead to static and dynamic analysis. So how today is going to be structured is, I think for the first maybe 30 plus minutes, we're going to play a game. We're going to play a game of where's the bad code? Pinpoint the bad code. Now, here's the good news. Now, the thing about cybersecurity is you don't need to be a master programmer. You don't need to have all the programming skills in the world. You do need to have some basic skills, like basic programming. Like you have to know what a for loop is, an if statement. You got to know that stuff, at the very least. But I don't expect everyone to know everything to be like a programming ninja or an expert. Well, then again, very few people are. Hello, Bot Ranger. Okay. You don't even need to be good with like every single language. Now, I know a bunch of you here probably don't know Java. You probably don't know JavaScript. Some of you probably don't know JavaScript. And there's probably a good handful of you that are not comfortable with C. Okay? But I want to start out with 3 code examples. Okay? Here I am. Oh, speaking of bad code, and speaking of mistakes that you can't make, here you go. This was from, a few weeks ago. SolarWinds. Hard-coded credentials again. Okay? So, in that spirit, I have right here, I'm logged in to my home server. I'm going to do an LS, and there are 1, 2, 3 examples of bad code. One is in Java. One is in JavaScript. Java and JavaScript are not the same. They're 2 different programming languages, and one in C. Okay? Java, JavaScript, and C. Like, these are some examples of bad code. Now, I want to ask you folks, what do you want to start off with first? What would you like to start off with first? And again, you don't even know it. You don't need to even know the language. I'm sure when we show you the examples, you can probably pinpoint the vulnerability right away. Pick. All right, we got Java. We got Bot Ranger picks Java. Anyone else? Any other votes? We got Java. Anyone else want to chime in? Ooh, Herb said C. Ooh, okay, we got a C vote here. Anyone else? Now, Herb says C. Anyone else? We have Java, we have C, and we have JavaScript. Okay. This is what we're going to do. Let's do this. We'll start out with Java. Then we'll do the C example. I don't know Java, but look at an example on how to use the code. All right. Let's do that. Let's do Java first, then C, then JavaScript. Let's do that in that order. Also, let's not even run the code. Okay? We're not even going to run code. Actually, I lied. Let's not run code yet. Let's not run the code yet. No code execution. There's a reason for that. I'm sure even without even running the code, you can spot the vulnerability. Okay? So let's do Java, C, and JavaScript. All right. Now, all three of these examples, bad code examples, are compilable and runnable. That's a key. There's no syntax error. No syntax error on any of these three examples. So I am going to show you the Java example first. Are you ready? I'm going to show you the JavaScript example. Actually, I'll do one better. I'll just open up my Visual Studio Code. We're not even going to run the code. We're not even going to run code. I will need the terminal later. We're going to run it a little bit later. Bing! Let's go to Java. Ready? Get out of here. That's it. 25 lines. All right, folks. Here's the Java code. Pinpoint where the problems. Let's go. Have a ball. Also, an FYI, if you are doing if you're doing an interview, a job interview for cybersecurity roles, especially in application security, like these are this is actually a type of question you will get. I know Amazon does this for application security roles. Here's the code. Pinpoint the problem, the serious problems. Okay. Meat Left Fish said, I don't think it sanitized inputs. For SQL, that is correct. That's one. No, there's no sanitization of input. Nope, none. Okay, go on. This one, for this code example, there are two really glaring ones. And you can probably say, I would say, roughly at least six serious problems, 6 issues. Okay, in the variable, what variable? Oh, variable, the IP address. All right, come on. I don't care if you know Java or not. Doesn't matter. You should be able to pinpoint the vulnerabilities. Okay, the variables, the IP address. Yeah. Anyone else? Okay, we need to go a little bit deeper. There's a whole slew of problems here. There are two 5 alarm fires here. The execute query part, how so come? Like with no check, just do it. Yeah, just do it. Okay. What are the vulnerabilities? What are the specific vulnerabilities? The specific vulnerabilities. Like with no checks or anything. Ooh. Yeah, evil, stupid Tony. That's a big one. Why is the username root? That's a big problem. Yeah, that's a big one too. Again, you should be able to pinpoint at least two really 5 alarm fires. Overall, there are at least six like serious problems. Yep, the password is hard coded. Oh yes, the password is hard coded. The IP address seems local, not Twitter itself. That's true, yes, but that's not the major vulnerability. But still, exposing addresses and hard coding addresses like that is not cool. Yeah, Kalam says the passwords are hard coded in plain text. Yeah, that one is not okay. What was the last Twitch session that we did? The last Twitch class that we did was the mistakes that you cannot make. Hard coded credentials, not okay. This is not okay. Um, okay, so let's get to the two major vulnerabilities, the 5 alarm vulnerabilities. 5 alarm vulnerability number one, unforgivable vulnerability, hard coded credentials. That's number one. Like, this is not okay. Hard coded username, hard coded password, and a source code. This is not okay at all. Absolutely not okay. This is hard coded in the source code. No. But you also have another problem here, a second problem, which is pretty bad as well. It seems like that this is to connect to some sort. Well, this is to connect to some database, using a database driver somewhere. Why in the world is a username root? So root anything is, super user privileges. So you have another problem, which is you're using root as a username in an account for an account here. It seems like, yeah, this is a MySQL. For a MySQL database, you should never ever, unless you have exceptions. Unless you have reason to do so, you always create separate non-root users for database access. Never root. So once you actually log into an account with root, it has access to everything. Okay, that's not okay. So 5 alarm fire number one, not okay. Hard coded credentials, like not good. 5 alarm fire number two, as a few of you alluded to, is number 13, line number 13. First of all, the user input is not even sanitized. Okay? arg0 args is the array for user input. Nothing is sanitized at all. This is really SQL injection. Okay, line number 13 is the mixture of a computer program and data, user input. This is used for a SQL query. Line number 13 is SQL injection. Line number 13 is, and also 14 for that matter, is SQL injection. So this is 5 alarm fire number two. This is not good. 5 alarm, like these are not 5 alarm fires, but these are still serious problems. I already mentioned the user account being used here. There's a root user, that's not good. Couple of other problems is line number one, import the Java SQL, the SQL library in Java. This is importing everything, which is noted by the wildcard. You only import the stuff that you need. So line number one, you're importing the entire SQL library in Java. That's a lot of stuff. This is a code quality problem and also may possibly lead to performance issues. This is not good. Okay. The root user I already mentioned. Number three, another, actually not number three, another vulnerability, another issue with, um, actually it is a vulnerability. Line number 20. Look it, when something goes wrong, when there is exception, when something goes wrong, it's going to print out, whoops, something went terribly wrong, plus the exception. This is not good. This is information disclosure. The problem with this is you never, even when a program crashes, you never print out the entire stack trace or exactly the technical details on what happened to the user on a screen, such as a terminal screen or a browser. You never do that. The way you resolve this problem is you resolve this problem by look at when you are need to handle exceptions, you always log exceptions behind the scene using like a logger or a database. And I mean, there's one you can use by default in Java called logger. But you never ever print out exceptions or when things go wrong to the user. That bad form. Okay. Is that because that's a need to know thing or keep it user for activity and user? The reason is actually it's a mixture of both. It's really more of the need to know thing. First of all, you never tell the user that, whoops, something went terribly wrong with, oh, line number 13 with this SQL syntax error on SQL statement. You just gave away that there was a SQL injection vulnerability. So Columba's great question. Actually, it's a matter of both things. Is both need to know and also keep it user for the end user. All you need to just say for the end user is something went terribly wrong. We're looking into it. Something blah blah blah. Something like that. But never give out the full details. There's also another problem here that will ultimately hurt you. I don't think a lot of people. I don't think a lot of people have done database development. Have actually worked with databases before. But the idea is very, you get this idea. Line number 10 is when you open a database connection. But what's missing? There's something badly missing here. And this will, again, ultimately hurt you. I'll give you a hint. If you ever taken a basic introduction to computer science, intro to computer science course, you're probably going to write a computer program that opens a file, then you do some reading and writing, but then you have to do what? At the very end? Close or release. That's correct, as what Evil Stupid Tony said. Yeah, when you open a file, anytime you open something, like a file for reading or writing, you have to close it. Here, in this program, the database connection is not closed at all. It should be con.close as a function. The close is a function. There's no closing of the database here. So, old war story when I was writing Java web apps in the 2000s. I built many web apps using Java back in the days. And there were times that certain apps that opened up database connections would ultimately fail at the end of the week. Like a training database for record keeping of who takes compliance trainings like slip, trip, and fall, lab safety, occupational safety, the list goes on. And at the end of the week, the database application would fail for everyone, and everyone would actually get an error message on the screen saying that, no connection could be made. And what happened was the way that I was building the web app back then was very much like this code. And the reason is that, well, the memory got exhausted. That is, let's say we have 1,000 connections to the system. There were, at the end of the week, there were like 1,000 database connections that were lingering. They were never closed. And that's a serious problem. When you open up a database or a file or anything for reading or writing, you got to close it. There's no closing of the database here. Yeah. Yeah, you have to do, at the end, you have to do like a finally clause, and then you just close the database. Okay. So here, there's a whole slew of issues that we just talked about with this code. Working backwards, close the database connection. That's number one. Number two, only import the certain subpackages or functions that you need. So don't do like java.sql.asterisk. Like, this is bad form. This is just really bad programming. Number three is sanitize the user input. Number four, for logging, don't ever print out exceptions to the screen to the end user. Always log it behind the scene. Log it into an external database or some logging software that is used. The hard-coded credentials. This is a big one. First of all, when you're making a database connection, always use a non-root account. Hey, even Linux systems now have done away with root user. Okay? But the big ones are, okay, what about line number 13, the SQL injection mixing code and data, and the hard-coded credentials? Like, how do you prevent this from happening? How do you prevent this from happening? Well, to eliminate the SQL injection problem, this is a good review, is to use prepared statements. Okay, there it is. Number one, prepared statements. Okay. And an important advantage of prepared statements is that they prevent SQL injection attacks. Instead of hard coding queries like blah, set placeholders. So you would do this instead. You use prepared statement. Don't do string concatenation. That's the whole point. And largely, everything else looks the same, like execute query still looks the same. Yeah. There's really not that much work to do to actually go from string concatenation to prepared statements. Not much at all. Okay. So use prepared statements. What about hard-coded credentials? How do we eliminate this problem? What you do is, instead of hard-coding the username and password, you store the username and password in memory. Then you actually have the program, this Java code, actually make a call to get the username and password, and even the URL from memory. Okay? So what you do is something called environment variables. Java environment variables. And please understand, this concept of environment variables goes through any programming language. Python, Ruby, C, C++, certainly Java. Set environment variables in runtime in Java. Okay? Provides a simple way of interacting with environment variables. We can access them, but we cannot change them easily. However, in some cases, we need yada, yada, yada. So really, all you need to do is system.getEnv to get the environment variable, and that's it. System.getEnv. So all you got to do is, instead of saying username equals inside, well, let's use the password for example. Instead of humanhorn 2016, you would do system.getEnv, the variable that's on your system that has that password. And there are so many. You can actually, on a system like Mac, Windows, you can set all kinds of environment variables that you want. And let's do man print env. Print out the environment. Okay? So the environment really is just a system-wide key value, just a system-wide key value pair collection. So if I do print env right now, I don't think I have anything sensitive. You can see that all the different types of environment variables, term underscore program, the shell, RVM path, log name, it's mchow, yeah. So log name would be the environment variable name, and mchow will be the value. Print env is just going to print out a collection of what they call environment variables on your system. And you can set as many key value pairs, environment variables, that you want on a system. Here, that's the official Java document. Many operating systems use environment variables to pass configuration information to applications. This includes path, username, password, yada, yada, yada. Yep. System.getEnv. That's all you need to do. Okay? All you need to do. So instead of hard coding stuff, just store all the values on your computer or in memory. Okay? So, but you never hard code stuff. Never hard code stuff. So this is a Java example. So this one have at least 6 major issues here. Too much being imported, root user, hard-coded username and password, SQL injection, not using prepared statements, logging, no logging at all, just printing, dumping stuff out the screen, not closing the database. All right. So you didn't need to know everything about Java for that. You just have to pinpoint the major issues. There you go. Okay, so this is a Java example. Now let's move on to C. Okay? This may sound really daunting. This may be really daunting, but no, not really. Here's the code. Tell me what a vulnerability is. Really, it boils down to one line. I'll give you that. Where is a vulnerability? All you need to do is show the line number. Just say the line number. And this could actually, remember how I said earlier that this conversation can get really interesting? I think this, especially this example, can lead to a talking point or many. Why line number 15? Ayub said 16. I want to hear Ayub. Why 16? Now I'm really interested. Ayub says 16. I want to hear your rationale. You're correct. It is line number 6. 16 is the problem. "16 is the problem." Okay, so let me just go through a really quick overview, especially the early part. In this code, there are 2 character arrays, buffer underscore 1 and buffer underscore 2. Both are of length 8. Initially, what will happen is the string 1 will be put into buffer underscore 1, and then the string 2 will be put into buffer underscore 2. Okay? Oh, Ayurb says because argv doesn't have a size, that's correct, and buffer underscore 2 does. I think you're getting the idea. Okay. That's correct. Generally speaking, Ayurb, you're correct. Okay? But there's nothing preventing you from entering. You're absolutely correct. Ayurb is correct because the input argv, there's no size limit. None at all. None at all. Your user input can be as long as possible. But here, yes, you're right. Buffer underscore 2, there is a length limit, 8 characters only. The crux of the matter is stir copy. Stir copy is copy a string into a buffer. In this case is copy the user input into buffer underscore 2. Here is the problem, the serious problem, especially with C, and also C++ for that matter. There's no bounds checking in C. I repeat, there's no bounds checking in C. C does not actually have any bounds checking. There's nothing like C is just going to do it. But when the program blows up, boom, there you go. Okay? The real crux of the problem is the using of functions like stir copy. Now, I want to ask you folks here, for those of you who have actually done any work in C or C++, have you learned anything about the function that you should never ever use? Oh boy, this is going to be not a fun topic of not this shit again. Alright, that's not a good sign. How many people here have done it, like an intro to programming course, an intro to computer science course, use C, C++. If any time has a professor or an instructor ever taught you the function that you should never ever use? Okay, I'm hearing radio silence here. Okay, count Celsius, yep, it is stir copy. I'm sure a lot of you folks have used stir copy before, but you really should not be using stir copy at all. That's what Count Celsius said. Okay, this is not good. Yeah, I had a bad feeling that this is still non-existent. Alright, folks. Let me introduce to you to what I call the dirtiest of the dirty. Do you need to know this? Yes. Yes, you do. I want to introduce you to CERN. Oh. Okay. You see, Nicole, you win the internets for the day. Nicole, you win the internets for the day. Yes, that's correct. You got the education that you deserve, which is a good education. An award-winning one. Here. Count Celsius. I just dedicated to Count Celsius. Count Celsius, you win the internets for the day. Common Vulnerabilities Guide for C Programmers. Most vulnerabilities in C are related to buffer overflow and string manipulation. In most cases, this would result in something called, have you ever heard of something called segfault before? Also, on that note, do they still give zeros in the assembly and architecture course CS40? Do they still give automatic zeros in CS40 if you have a segfault or a dump core? Please tell me the answer is still yes. Okay, good. Excellent. But specifically crafted malicious input values adapted to architecture and environment could yield arbitrary code execution. You will find a list of some of the most common errors and suggested fixes and solution. Anyone ever use get s? The standard IO get S function does not check for buffer length and always result in a vulnerability. Mitigation prefer using fgets and dynamically allocated memory. Here it is, stir copy. The stir copy built-in function does not check buffer length and may very well overwrite memory zone contiguous to the intended destination. In fact, a whole family of functions is similarly vulnerable. Stir copy, stir cat, stir cmp, stir compare. There you go. The best way to mitigate this issue is to use stir lcopy if it is readily available, which is only in the case of BSD systems. However, it is very simple to define it yourself as shown below. So what it is stir copy with length checking. Actually, in this case, with a length requirement argument to the function. Stir lcopy. Okay, there you go. Another and maybe slight less convenient way is to use stern copy, which prevents buffer overflows but does not guarantee null termination. Okay? For other functions in the family, the N variant exists as well. Stern CPM or CMP and stern cat. Okay? Does memcopy also work? I believe so. Look it up. Oh! Oh! There you go. Oh! For iUrb. Woo! Microsoft provides alternative to memcopy and WMM copy that validate their parameters. A chainsaw, if used properly, is safe. Same thing with memcopy. But in both cases, if you hit a nail, it can fly and hurt you. In short, memcopy is required for low-level programming and won't go away, but for high-level programming, there's no memcopy. Okay, don't bother. Okay, I think there's a, here it is. Memcopy underscore S. Actually, hold on. Microsoft stir copy. Let me see the Microsoft documentation for stir copy. Here you go. Stir copy from Microsoft. Take a look. From updated pretty recently. This should be a big, ugly warning here. Copy the string. Here it is. More secure versions of these available. Here it is. More secure versions of these functions are available. See stir copy. Yes, there we go. Copy the string. These versions of stir copy, WCS copy, have security enhancements. This is what you should be using. Okay. Microsoft memcopy. Copied buffers. Okay. More secure versions of these functions are available. There you go. Okay. So there you go, iUrb. Ding. Yep. Memcopy underscore S. WMemcopy underscore S. Yep, they put a buffer size. Yeah. Okay, this is good. iUrb also gets a gold star. sprintf just says previous function sprintf does not check for buffer boundaries and okay. So now you get the idea. There's no bounds checking in C. Love that line about the like a handsaw by itself is, you can use it. You just have to be careful. But you know that most programmers and don't care even up to this day. So here. So I guess my big question for each and every one of you, for those of you who have actually used and learned C or before, this is the first time you've ever heard of this? This stuff should be taught in the intro courses. Why the f is this not taught in the intro courses? It just really bothers me up to this day. Not good. Yeah, well, that's the thing. One thing, what did someone actually say about C in general, to be honest? One person I've known many years ago said C is like, you know, yeah, it's like a hand. I think the clean version of what the person said was, it's like a handsaw. You can cut your thumbs off with it if you want. Yeah. Well, actually show you what happens when I run this. But again, I'm not going to run this yet because that's not the. I don't want to do that yet. So again, not going to run the code. But yes, now you know the vulnerability is stir copy. The mitigation is don't use stir copy. Use a safer version of stir copy with bound checking. And this basically also, to Ayurb's point, goes for almost every other function in C. There. Okay? So stir copy, really bad. Stir L copy, a stir N copy, good. Okay. One more. Let's do JavaScript. Node.js. Alright, this one is, I feel this one, I don't care, yeah, it looks like spaghetti code, but you should be able to pinpoint a vulnerability just like that. Especially if you played the Capture the Flag game last week. Well, for what, 2 weeks? It's only been 2 weeks that you played that game for. I'm not going to run this thing yet. Where's the vulnerability? Where's the issue? There you go. Panic House 38 nailed it right in the head. It is eval. Okay. What in the world is eval? Every single programming language has a function called eval. Eval, I love this one. This is actually perfect. This is Mozilla MDN. This is just awful. Yeah, you got to sanitize the chunks too. This one is too easy. The vulnerability is, well, eval. What eval does, it just takes in user input as a string. User input is always a string. Evaluates it as JavaScript code. That's it. And returns its completion value. Yeah, so the eval function takes in like a value as a string, evaluates it as code. And executing JavaScript from a string is an enormous security risk. It is far too easy for a bad actor to run arbitrary code when you use eval. Just see, never use eval below. There. This is how eval works. Eval takes in a string, evaluates it as code. That's it. Eval is a function of, okay, PHP eval. Evaluates a given code as PHP. Caution, the eval language construct is very dangerous because it allows arbitrary execution, arbitrary PHP code. Its users thus discouraged. Look, here's the bottom line. Eval is evil. Don't use eval. Okay? When is eval not evil? Eval is evil. I'd like to take a moment to is that eval is evil. The word evil is dangerous, yada yada yada. So when is it okay? The reason why eval is considered evil are performance and code injection. Well, you're not addressing the issue. when you trust the source. I can tell you where eval is actually used. Um, eval is actually, if I'm not mistaken, is used in the JSON parsing libraries. Yeah, eval is using the JSON parsing library by Doug Crockford. Okay. What is this site? Yeah. Look at like dynamic code execution. Like, good luck with that. I mean, there's a reason why. Look at it's an enormous security risk. Hey, this is a security course. It's far too easy for a bat, which has been proven true all the time. Never use direct use. Okay, here it is. Look, I'm just gonna say it right now. Just don't use eval. It boils down to that. Okay, this is a security course. Code injection is still a big problem these days. Just, just don't. Okay. What was the purpose of it when it was added to JS? Probably ease of use. Yeah. Why eval? No. Here's the thing about what column you just said. Eval is in every single programming language. Every single. This is Python in eval. Here it is. Python is not used due to security reasons, as we spoke above. It comes in a handy situation, such as if you want to write scriptlets, but that's kind of a weak thing for evaluating math explanation. But that's easier to write. Okay, that's right. This is much easier than writing an expression parser. I'm like, okay, but that's kind of weak. No, I mean eval is in every single language. No, eval is in every single programming language. Python, PHP, Ruby, eval. There you go. C, Java. Hey, just don't use eval. Yep, even Java has it. Every single programming language has eval. Alright, the bottom line is don't use eval. It's just too easy to make a mistake. Okay? So here we go. The issue is eval. That's it. Vulnerability, eval. How you defend against this problem? What's the mitigation? Don't use eval. That's it. So we just done 3 examples: Java, C, and JavaScript. 3 examples. 3 examples of really bad code. But if you notice, recall the pattern of today. We didn't even need to execute code at all. We didn't even need to run the program. We need to do absolutely nothing. We just eyeballed the code and we were able to pinpoint the vulnerability just like that. All we had to do. All we did was we just eyeballed the code and we just pinpointed the vulnerabilities and the issues. No execution of code. That's it. For small programs, it works very well. Just all you need is a set of eyeballs. But if you have a large code base with millions of lines of code, hundreds of thousands of files, well, you can't eyeball them all. But the same premise exists. There are 2 terms that you really have to know. There are 2 terms that you really have to know. And now, the 2 terms that really the whole gist of today is static analysis and dynamic analysis. Static analysis and dynamic analysis. You need to know the difference by the end of today. What we have been doing for the last 30 minutes or so have been static analysis. Eyeballing the code, no execution of code. Just looking at the code. Okay? So here's the difference. I actually wrote this down. Might as well use it. Here's analysis. The 2 that you gotta know. Static analysis is the idea of code scanning. Okay, think of it as code scanning. Alright? There is absolutely no execution of code or program, including compilation. The good news is static analysis will always produce 100% code coverage, including parts of program that will never ever be executed or even can't even be reached. The problem with static analysis is you're gonna get a lot of, it's noisy. There are gonna be a lot of stuff and results. Lots of false positives, including stuff that you don't care about. Okay? And this is the reason why a lot of people shy away from static analysis, because you get so much, so many results, and a lot of them you don't care about. Another big problem is that there's not going to be able to find configuration issues with a software or a system, because um, you need to have a system running in order to find configuration issues. It can't find any runtime issues because, of course, it can't by definition. Duh. Good examples of, there are so many static analysis tools out there, too many to list. The most famous one is lint. Linting, have you ever heard the term called linting of code? A code linter, what it will do is just going to find all sorts of problems. Let's say JavaScript lint, JS lint. Every single programming language has a linting tool for code quality and coverage. Here's JS lint. This is free, and it's open free. Here it is. And all you need to do is really simple to use. Copy the code, paste it in, JS lint, linting. And as you can see now, it's going to actually say every single line of code is problematic. Use double quote, not even stuff like this. Use double quote, not single quotes. Tabs, spaces, not tabs. It's not just picky, it's uber picky. Undeclared. What's the eval here? Unexpected eval. Okay. ESLint. Here you go. You can use ESLint that you can use for NPM. Overall, linting is good stuff. Same thing. Okay. So many linting tools out there. Each and every single programming language has a linter. Okay. Do this again. Yeah. There's just so much stuff out there. The problem with static analysis tools is that there's just a plethora. Is linting why it's called fuzzing when? No. Linting and fuzzing are two different things. Linting is actually just going to check your code. Fuzzing, on the other hand, is just throw all sorts of garbage at a running program and hope it crashes, which would usually mean some sort of a vulnerability or not. That's the difference. Linting and fuzzing are two different things. Linting is actually just code scanning. Fuzzing is just throwing all sorts of garbage inputs and stuff to a running program and see if it crashes. Which has a lot of value. Yeah, you know what? I'm just going to say, also, you bring up an interesting topic because I've been thinking about this. I think for starting spring 2025, I'm going to do away with quizzes for the security class. Like, what's the point? Like, now we live in different times. I will add a few more lab, but one of them will be a fuzzer. Like, students will have to write a fuzzer to crash a program or to conduct cross-site scripting or something like that. So more lab, no exams. I heard 105. Oh, speaking of programming language, like Flow is a JavaScript program. That's another static analysis tool. For those of you who have taken CS 105 programming languages, the type checker. The type checker is an example of a static analysis tool, like to do types. So you may be wondering, what the hell does that have to do with security? It does. So for years when I taught web programming, CS20, one of the labs in the course was always to create a front-end Google map of where everyone is, or where, like, national landmarks, list goes on. And all those landmarks are stored in some sort of a MongoDB, or some sort of a database. But I always tell people, for geolocation point, latitude and longitude. Latitude and longitude. What is the data type of a latitude and longitude? Double or floating point integers. Like, I tell everyone this. Latitude and longitude, doubles or floating point numbers. It's never a string. In Google Maps, if you use latitude and longitude as strings, they actually say in the documentation, no, latitude and longitude that you use for markers and point have to be numbers, not strings. We're not going to render, the map is not going to render if you actually use strings for points, geolocation point. And of course, students actually don't, they always complain, oh, the Google Map doesn't render on the web browser screen. And of course, yeah, we know why, because obviously your database did not actually convert the latitude and longitude from string to number. There. You get that, that's an example of a type checker. That's why type checking is important. Okay? Latitude and longitude, for example, must be numbers, not strings, because the Google Map is not going to render if they're strings. Okay? There is Infer, that's written by Facebook, that's free and open source. Flow, I think, is free and open source. Veracode is public, is private. I have an example of that. GitHub code scanning is now available. I'll show you a bunch of them. I think I have a bunch of them queued up here. Oh, hello. There you go. Flow. Flow.org. There's a type checker. JavaScript. I think Flow was written by Facebook, Meta. Flow is a static type checker for JavaScript. Flow, okay. Yep. Yep, open my Meta. There's also Infer. Also done by Meta. This is a little old. I have always had trouble with this. Infer. This is a static analysis tool for Java, C++, C++, and Objective-C. If you can infer some Java or C++ code, it produces a list of potential bugs. Anyone can use Infer to intercept the critical bugs. Okay. For Java and Android, here we go. I'll just run this example. Infer checks for null pointer exception, resource leaks. Very good. Concurrency, race conditions, and Android and Java code. Nice. Okay, no issues. Oh. Oh. Okay, cool. Alright, that's free and open source. What else we have? Code scanning, and yep, here it is. You can use code scanning to find vulnerabilities and errors for your code and project. Yeah, this is for anyone who uses GitHub. Code scanning is a feature that you use to analyze the code in JavaScript and GitHub repository to find security vulnerabilities and code errors. Any problem that you identified by the analysis are shown below in your repository. And you can use third-party scanning tools as well. If anyone ever do Ruby on Ruby, Stripe built this tool called Sorbet. It's a type checker for Ruby. Yeah, Stripe actually uses Ruby quite a bit. Today, Sorbet runs over Stripe's entire code base, Ruby code base, 15 million lines of code, spread across 150,000 files. You can't take, okay, here you go. Yes, and let me show you Veracode. Now, for years, Veracode was founded by one of the founders, Chris Weissoppel, Well Pond, a friend of mine, a good friend. Give a shout out to Chris and Veracode, the team at Veracode, based in Boston, Burlington, Massachusetts. Their bread and butter is a static analysis tool. Okay, their bread and butter for years has always been, no, get me out of here, static analysis, Veracode. And this is commercial. Secure code in every phase of development. Okay, I'll show you an example of a report. I think I have a report here of some sort. Is this one? Nope. I know one of these is. Nope. Nope, not that one. The hell is it? Oh. Bing! Oh, detailed report. Yeah, here it is. Detailed report. Yep. From 2017. This is an example of a Veracode report from their static analysis tool. Trusty former student Taddy Doyle wrote this Python program in 2017, a Facebook follower counter bot. And this is what Veracode static analysis will do. Like back in the days, I required students to use Veracode to scan the entire capture the flag game. You know, the one that's the source code of the entire capture the flag game. So what it will give you is a score on a scale of 0 to 100. Usual A, B, C, D scale. So in this case, the score is a 74, which is a C. Executive summary here. Summary of flaws found. One very high, a bunch of mediums. Here it is. Scope of the static scan. Here we go. Very high vulnerabilities. 2 code injection. No high. There's a cross-site scripting, a directory traversal. Yeah, these are things that static analysis tool, good static analysis tool will find, including hard-coded passwords. Directory traversal. Oh yeah. It will actually, one of the things that static analysis tool will do, it will pinpoint the vulnerability where it is. Like for example, 2 code injection flaws. In this program, launch.py at 30, launch.py 30 line 31, that's where the code injection is, CWE 95. But in terms of the fix to make, that's something else. It usually doesn't do a good job improving or fixing vulnerabilities. Static analysis will pinpoint vulnerabilities, but not really fix. Where's the cross-site scripting one? Here it is. Cross-site scripting, 3 flaws. Cross-site scripting is, no, that's not HTML. No, that's bullshit. Come on, guys. It shows here it is. Bot.py, line 63, and then debugger.js, 79 and 159. Cross-site scripting vulnerability. So pinpoint where the vulnerability is, but won't fix it. Like, it's not going to fix it for you. It just tell you, yep. You have to go and verify it and also fix the vulnerability yourself. But static analysis tools is now like a norm. Like, get into that. If you're doing any programming or coding, get into the habit of using static analysis tools as part of your arsenal for development. Okay? Yeah, so that's a whole bunch of this, like a plethora of static analysis tools that you can use. But really, the idea is no code. It's just code scanning, no execution of the code or the programming or the program. And really, what the whole gist of the next lab in security, lab number 9, second to last lab of the security class, technical risk analysis. What it is a static analysis exercise. It really is a static analysis exercise. I give you the entire source code. You definitely need to take a peruse through it. You shouldn't take hours on it. You can just eyeball some of the code, and some vulnerabilities should just, boom, pick up just like that. And you're just going to build a table. I mean, of course, the example here that we use is user authentication of brute force to WordPress can be brute force. That's one vulnerability. I'll give you a freebie right now in the air. Obviously, SQL injection is going to be a big one that you need to talk about. That's a freebie. Okay. This one, I just want to give you a little heads up. It's probably the easiest grade by far and away for me to grade. This one's easy for me to grade. Okay, and there is a bonus to use it, both create and run a static analysis scan of the entire capture the flag game. In the past, I required, in order to get the bonus, you had to use Veracode, but this time you can use any static analysis tool that you want. A lot of students use SYNK, also pronounced sneak, SNYK, sorry. So many students use SNY, so many people use SNYK now. Just want to give you a heads up to look into this. Definitely use it for your work. Sneak. Okay. Now, on the other hand, dynamic analysis is the opposite of static analysis. Is a lot of it's trial and error. Unlike static analysis, it requires execution and running of a computer of code or a program. The good news is dynamic analysis is great to determine things like configuration issues, memory leaks, goes on. The problem with dynamic analysis, it won't have 100% code coverage. No, there's no code scanning. Dynamic analysis means runtime execution of code. The most famous example of a dynamic analysis tool by far and away is Valgrind. Yeah, please tell me that they use Valgrind now in the intro courses at Tufts 11, 15, and 40. Please tell me that they use Valgrind. Yep, here it is, in an instrumentation framework for building dynamic analysis. We do, okay. Is it using 11 and 15, the intro courses and data structure? Please tell me that is true. You know who was behind using Valgrind in 40, right? You know who the person was that used that started it all? Anyone? Who was the one that used Valgrind? Anyone want to take a guess? Well, the wild guess is not me. It's a good one. Norman Ramsey. He created both CS40 and 105. And this was like in the mid-2000s, and he started using Valgrind for 40. He was the one that introduced Valgrind. And for years, the problem for years has always been the jump from 15, the data structure course, to 40 has always been like an abyss. It's like jumping from like tier one, like going from 0 to 100. And so it was like for years, the jump from 15, the data structures course, to the assembly course, was an abyss. Um, Believe it or not, the person who introduced Valgrind to data structures CS15 was me. Yeah, I taught 15 for a good few years in the 2010s, 11, 12, and 13. Yeah, no one died. It was like a wild roller coaster. We had a lot of fun. It was really fun. But yeah, I was the one that introduced Valgrind in 15, so the jump wouldn't be so bad. So yes, the person responsible for the use of Valgrind in the second course, data structures, is me. But overall, it was Norman Ramsey. So now you know. I want to, before we go, remember I said we are not going to run code until the very end? Well, let's do it out, folks. Now, let me show you phone.c again. There you go. Alright. Let me do gcc -o run me phone.c. Okay. Now, modern C systems will have something called stack protector. So you can't do things what is called a buffer overflow. So if I do if I do run me now, I'll get a segmentation fault. Alright, what happens if I do run A? Okay, that looks good, that looks good. 2 A's. Okay, that looks good, that looks good. 3 A's. That looks good, that looks good. 4 A's. That looks good, that looks good. 5, 6, 7, 8. Boom. Smashing stack detected, terminated. Abort core dump. This ain't good. I'm going to turn this off now. I'm going to turn off stack smashing detection. Now I'm going to compile vuln.c. Hey, buddy. Without stack protector. Take a look. Want you to all take a visual snapshot of vuln.c. There's a number going to be stored. The string 1 is going to be in buffer underscore 1. The string 2 is going to be in buffer underscore 2. Now I'm going to clear the screen. And I'm going to run me with 5 A's. Buffer underscore 2 is, okay, this looks good. This looks good. Vol value is 5. Okay. You can see the memory addresses of buffer underscore 2 and buffer underscore 1 and also value. Okay. What will happen if I do 6 A's? Okay, so far so good. Nothing egregiously wrong right now. Okay, this looks good. This looks good. 7 A's. Looks okay. Nothing looks too crazy right now. Buffer underscore 1 still looks good. Value still looks good. What happens if I do 8 A's? Uh-oh. Uh-oh. 9 A's. 10 A's. Uh-oh. Uh-oh. 11. 12. Well, value is still 5. But for how... Uh-oh. 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 What? Why is it 0x616161? Does anyone know? Anyone take a wild guess? What's the whole point of 61? Uh-oh. 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 Boom. copying 31 bytes into buffer underscore 2, and this is where you get something called buffer overflow. And you can exploit this. Hard to do now. Back in the ye good old days of the 2000, definitely very doable. Now, pain in the ass to do. That's why I don't do exploitation of buffer overflows in this course. A pain to do. But now at least you see what buffer overflow is. Here we go. This is not good. Now you have not one, not two, but three buffers completely overfilled. Buffer underscore 2, buffer underscore 1, and of course value. Not good. Not good at all. Okay? And this is the dangers of no bounds checking, and ultimately that leads to buffer overflows. Not good. Not good. Woo! Alright, let's do server.js. Node.js, how do you run this? What is my IP on this thing? 231. Node server.js. I'm going to open up a brand new terminal tab. There's the code again. Keep an eyeball on it. So you need to make an HTTP post request to the IP address at port 3000. It's going to take in whatever data gets sent by HTTP post. How you make an HTTP post request, you can do by way of something called curl. So you can do curl minus data, hello, HTTP. I'm going to open up another command, get some data, hello, and then I had to hit the control C. So I am going to say crumb1 was here, and that's the server, and end. But where the problem goes in is this, when you have eval. What happens if I do curl minus data? This console.log is the equivalent of a print statement in JavaScript. But what happened if we turn out JavaScript objects? Yes, in JavaScript Node.js, there is a request object, console.log. The request object. Holy shit. There's also a response object. And if you want to kill the server, I think is what? Process.exit. The process class or object, the exit function. Bang, quit. Eval is evil. So now we just did dynamic analysis of, well, manual dynamic analysis of two working programs. Now, with this said, you gotta know the difference between static versus dynamic analysis today. You can also do static analysis on binaries, like exe programs. I mean, it just reverse engineer the exe into assembly code and then just do a static analysis on that. So yes, you can do something called binary static analysis as well too. So, all this leads to one big topic. You've done a lot in this course. We just covered static and dynamic analysis. This all road leads to one last big topic. Malware. We'll start that next week. And yes, you'll be analyzing malware. That's it, folks. See you next week on Twitch. Yeah. Yeah, malware. All road leads to malware. You know, malicious software, viruses, worms, backdoors and stuff. Oh yeah. Thanks all. Have a good night.